Okay, today we're going to do Unit 3, Lesson 6, which is the the substitution method for solving systems of equations. This is completely brand new for us in Math 1, and it is definitely going to take some practice. Students definitely struggle with this method, okay? Substitution method is a way of solving the systems of equations by taking one equation and substituting it into another, and that is where it gets its name from, the substitution method. Okay, the steps that we're going to take to solve is, first we need one equation to be solved for either x or y. Sometimes it'll already be solved for one of the variables, and sometimes we're going to have to do it. Then step 2 would be to substitute that expression into the other equation and then solve for the variable. And then step 3 would be to substitute back in. So let's just walk through these steps in example number 1. So step 1, make sure that one of the equations is solved for either x or y. And right now they both already are. So what I'm going to do is I like to take the bottom equation. Let's take the bottom equation and write it right here, okay? But instead of the y equals, I'm going to replace that y equals with this other line. See how y also equals 4x minus 1. Brandon, don't touch stuff. Was that you? Okay. X also equals 4x minus 1. And then I'm going to bring down the 2x minus 5. So what I've done is I've replaced, instead of this y, I put the 4x minus 1. And now I can go ahead and solve this for x, just like a normal equation. So subtract 2 x's from both sides. I have 2x minus 1 equals negative 5. Add the 1. 2x equals negative 4. And if I do that division, I'm going to get that x equals negative 2. So I now know x equals negative 2. So here is the second part. I need to take this x equals negative 2, and I am then going to plug that into this equation. Okay, so I'm going to rewrite the equation here. Y equals 2x minus 5. But instead of the x, I'm going to plug in the negative 2. And then I can simplify this. So 2 times negative 2 is negative 4. Bring down everything else. Negative 4 minus 5 equals negative 9. And so I've done all the work. Now I just need to bring it all together. So I'm going to write my answer over here. My final answer should be an ordered pair. Remember, an ordered pair has an x value and a y value, and that's what I just found. I found x equals negative 2, and then I plugged that back in to find what the y value is, which is negative 9. So let's do another one of those. Okay, so I need to have at least one equation already solved for one variable, which I do have. And so I am going to go ahead and take that bottom equation. Okay, and let's see, the y variable here is all by itself. So I am going to replace the y with 6x when I rewrite this. So 2x plus 3 parenthesis equals negative 20. And I am going to plug in the 6x instead of the y. Okay, my alignment is a little bit off. Okay, so now I'm ready to solve this like normal. 3 times 6x is 18x. And then 2x plus 18x is 20x. And then negative 20 divided by 20, I get x equals negative 1. X equals negative 1. Now I could plug that x equals negative 1 back in to this equation here like I did in example 1, but I want to show you that you have options. So I'm not going to do that this time. What I'm actually going to plug it into is this original equation up here. Y equals 6x. So now I would have y equals 6 times negative 1. You can choose which equation to plug the first variable that you solve for back into. I like to choose the equation that is just the easiest to solve for. In this case, it was just 6 times negative 1, and I know that that equals negative 6, so I didn't have to do a lot of work. And then just remember to take your x equals negative 1 and your y equals negative 6 and put those together in an ordered pair. Now, sometimes if you were answering this as like a constructed response question where you have to type in the number, they might ask you to identify just the x value of the solution or even just the y value of the solution. Okay? So what I'd like for you to do now is to pause this video and try example 3 on your own. I'm going to leave example 2 up here where you can kind of follow what I've done. So give number 3 a try. Okay, so I have done the very first part, which is just the substitution. This is technically my step number 2. I didn't have to do step 1 because one equation already had a variable that was solved for a single variable, okay? Or one equation that was solved for a single variable. So if you can get this very first substitution part done on your own, then we can start working on building you into the final step, okay? So go ahead now, pause your video again and solve this down now that we've checked. All right, so now I have done the second part of the substitution, which is to take my x equals negative 7, and I plugged it into the blue equation because that was the simpler equation to solve. So now I know that the y value equals 2. My last step is to put them together. So x equals negative 7 and y equals positive 2. All right, great job. Now for example number 4, I would like for you to try this entire example on your own and then unpause the video. Welcome back. This is my example number 4, completely finished for you. The only thing that was different about this is that in that blue equation that I put a blue box around, the x variable is what was already solved and all by itself. So please keep in mind that it does not matter which variable is isolated and that you substitute in first. You can do either the x or the y, whichever one is more convenient for you. Now, if you flip your paper over, okay, you and a partner today or you individually on your own are going to do these problems, both the graphing method and the substitution method. And I just want to start us out doing number 2 at least together. Okay, and actually, no, let's do number 3 together. I just want to show you what it would look like if you had to do step number 1 first, which is to get one of the equations solved and so that a variable was all by itself, okay? So I'm going to choose the equation x plus y equals 9, and I'm just going to subtract over the x variable. And now I have y equals, you can put 9 minus x or negative x plus 9. It doesn't matter. Okay? And so now you have an equation that has a variable isolated. And now you're ready to go ahead and do your 2x minus 3, and because I got the y by itself, I will plug this in right there, negative x plus 9, and then that should equal negative 12. And then you're ready to solve the rest of that all the way through. I'm not going to finish solving it for you. You and your partner or you individually are going to complete that. All right. But I do want us to come down to the bottom of this paper, and we are going to do entirely numbers. Well, they are numbered 5 and 9. Okay. So we're going to do, and this is also what you're going to need to do with the assignment. You're going to need to both graph these equations and solve them algebraically. And I just want you to be able to compare and contrast what this looks like using either method. What we're going to do first is we're going to do the graphing method for number 5. So I have my red equation right here, and it already is solved for y equals. So I'm going to go ahead and graph it. On my graph, I'm going to go down 1, 2, 3, 4 on the y-axis, and then my slope is 2 over 1. So up 2 over 1, up 2 over 1. There it is. And so this equation, or this line rather, is going to look like this. You can also go down 2 and left 1, down 2 and left 1. And I like to try to go all the way from end to end on my paper, or at least close. Now for my blue equation, I'm going to have to do a little bit of work. So for the graphing method, both equations have to be solved for y equals before you can graph them. So let's just subtract our 6x, bring down negative 3y equals negative 6x plus 12, divide by the coefficient of y, which is negative 3, and so I get a slope of 2x and a y-intercept of negative 4. So let me erase that positive. Negative 4. Great. So now I'm ready to graph this, and this is going to be my blue line. So my y-intercept is negative 4, which is right here, and my slope is up 2 over 1, which is right there and there and there. So if I were to ask you if you're noticing anything here, I'm hoping that you would notice it. And that is that this blue line is right on top of this red line, meaning they are the same line. Remember from yesterday's video that when they are the same line, they are coinciding, so they have infinite solutions. Infinite solutions. I want you to see what that would look like using this substitution method. So I already see that this line is solved for one variable. So I'm going to bring this one over and get it ready to substitute into. And the y is what's by itself. So let's plug the y in. 6x minus 3 parentheses equals 12. And then in for the y goes 2x minus 4. And now we're ready to solve this like any normal equation. So let's distribute this negative 3, and that'll give me a positive 12, and then bring down this 6x. Okay, I'm going to combine like terms right here. 6x minus 6x is nothing. It's gone, right? Because it's 0. And I'm left with 12 equals 12. And if you remember back when we were just solving regular equations, if that ever happened to us, then what we would say is that it was infinite solutions. Okay, because this is a true statement. Okay, so my answer is infinite solutions. So that's what it looks like when I graph it on the left, and then over on the right is what it looks like when I do the algebraic method. Great. So keeping this in mind, what I'd like for you to do is pause the video, and I want you just to practice graphing method for number 9, and let's see what you get. And then when you're ready, come back and I'll have my graphing method up here already, and then we can do the algebraic method together. All right, welcome back. I have finished my graphing method for this last problem on the page. And if you, again, remember from yesterday, these lines are parallel. So when my lines are parallel, it means that they will never, ever intersect anywhere. That's just the definition of parallel. And so my answer is no solution. And you can write it like that, or you can write out the words no solution. Now, I just want you to see what that's going to look like algebraically. So I'm going to pick an equation to get one variable by itself. The easiest equation to do is the bottom one. I am simply going to add y to both sides because that only requires one step. And now I have x equals 2 plus y. So I'm going to plug that in for the x variable in that equation. And that's a 2 plus y in there. Minus 2y equals 14. Let's do our distributive property. 2 times 2 is 4. 2 times y is 2y. Okay, I've got some combining like terms here. 2y minus 2y. Again, that is gone. So bring down 4. So bring down the 4 and bring down the 14. And what I see here is that 4 equals 14, which is not true. So if I have a statement that is clearly not true, then I say I have no solution. And that's what it would look like algebraically. So you will be responsible for completing numbers 1, 2, 3, and 4 on your own or with a partner. You do need to do both the graphing method and the substitution method. But that's not all that you're responsible for. There is also a practice assignment posted for you on Google Classroom. So please make sure that you get all of these done. The graphing versus substitution, this part of your notes, will be a part of your notebook grade at the end of the quarter. The posted practice assignment will be an individual grade that goes directly into the grade book on its due date. Until next time.